Okay, 9.2, angles and angle measures. We're going to talk a little bit about radians today and talk about how we can calculate arc length a little bit faster than the way you did it in geometry. This is a hilarious cartoon. Hit pause, read it. Little review, cosecant, secant, and cotangent. Let's talk about these. Pythagorean theorem says this is 15. I would never do the cosecant. I would do the sine, and I know the sine is I'm standing up here. Be careful. 12 over 15, which means the cosecant is flipped over, right? 15 over 12. The cosine would be 9 over 15, so the secant is 15 over 9. And we could simplify these ones as well. And the tangent would be opposite over adjacent 12 ninths, so the cotangent is 9 twelfths. Write an equation for a ramp. I didn't draw that very well. It rises to a height of 3 feet. That's over here, 15-degree angle. What is the length of the ramp? The ramp would go up, so I would be talking opposite. I would be talking sine of 15 equals 3 over L, crisscross. L equals 3 divided by sine 15 degrees. There you go. Okay, we're going to talk about an angle measure. If it's positive, it's clockwise. This is standard position out to the right through 0. So clockwise is positive angles and counterclockwise is negative angles. So more often than not, we're going to start out to the right and we're going to go this direction. Draw an angle, 210. So I go 90, 180, 210. I like to make note that I went 30 degrees past that 180. That's going to be very important moving forward. 150. Again, I go around here, 150. Again, I'm 30 short of the 180. Very important. Negative 60. Now I'm going down. So the reference angle is actually 60. So this is negative 60. This angle with the x-axis is 60 degrees. 900 degrees, what am I doing? I'm doing a dive. So 900, here we go. 90, 180, 270, 360, 450, 540, 630, 720, 810, 900. So really I went 1, 2.5. I went 2.5 rotations. And then I hit the rotations, and then I hit the water. So well done, good dive. Give yourself a 10. 600, I'm going off a jump, and I'm going again, 360, 450, 540, okay? I'm coming out here, okay? And I may or may not be crashing and burning if I didn't land it properly. But that's 600 degrees, and again, we're going to be talking about 600 degrees. How far past did I go there? Past 540, I went 60 past. We'll talk about that later. Terminal side, terminal, to end, we terminate. Initial side, so we start here and we end up here, okay? So a 45-degree angle ends in exactly the same spot as a 315. So what we're looking for, find 2 coterminal angles for the 5 angles we just graphed. So you've got those graphs on your piece there. So what we're going to do, you can go 45 plus 360 equals, okay, that would equal what? 405. You can also go, and then where did the 315 come from? 45 minus 360 is negative 315. So basically you're going around the circle again. Think of it as a roundabout. So you got that 210 you just graphed. So I'm going to go, my 210 is here, but I could have gone 210 minus 360 would be negative 150. So negative 150 is the same as positive 210. I stop in the same spot. So I start there and I end there. There's 2 different ways to get it. Think about, and then when we go around, when I go plus 360 and I get 570, think about, I'm going around the roundabout again. I know all of you drivers have gone around these roundabouts more than once, okay? Possibly illegal, but we could keep going, plus 360, plus 360. Don't go the opposite way around a roundabout, bad things will happen. 150, going to be over here, right? And really what I can do is I can go plus 360 gives me 510, and minus 360 gives me negative 210. Those are coterminal, to end in the same spot. So 510 would be 360, and then another 150. So I end in the same position. Negative 210 goes this direction, 210. I end in the same spot. Negative 60, again, I can add 360. That's the same as a 300. So if I did a 300, I'd come around and I'd be 60 short. Well, if I do negative 60 and 300 is the same thing. So you can do negative 60 and you can minus 360, and I get negative 420, man. So I go around 360 and then another 60, and I end in the same spot. 900. Now if I wanted to get a negative, I got to go minus 360 is, go backwards. What is that? 540 minus another 360 is 180, minus another 360 is negative 180. So positive 180 stops here, negative 180 stops here, positive 540 stops here, positive 900 stops here. So we're all stopping in the same spot. 600, I can go plus 360 is 960. I can go minus 360, must be 240. And if I need to get a negative, I just go backwards another, go back again, negative 120. So negative 120 stops right there. That's the same as 240, positive 240, and negative 120. They stop in the same spot. More than one way to get to where you want to go. Okay, now we're going to talk about the big thing. What is a radian? So if this is the radius of a circle, and we turn ourselves the distance of one radius, we turn ourselves up one. So if this is r, this is r. The great thing about this is it's an r, okay? That means the angle formed is 1 radian. So when we talk about how many radii to go around the circle, there's 1, and then we go 2 and 3 and 4 and 5 and 6 and a little bit. And if you think about the distance around a circle is also called the circumference. And if you sing the song, pi r squared sounds like area to me. If you need circumference, just use pi d. Pi times diameter can also be written as, wait for it, 2 pi r. Oh my goodness, what is 2 pi? 2 pi is 6.28 radii. And what did we do when we went around the circle? 1, 2, 3, 4, 5. We went 6 radiuses and a little bit. That means that 2 pi radiuses, also known as 2 pi radians, gets us all the way around a circle. Holy cow. That means 2 pi radians is equal to 360 degrees. And that, my friends, is your ticket. You got to have a ticket. So here we go. What is a radian? 1 radian is the central angle formed when you turn the distance of 1 radius around a circle. And since every circle is similar to every other circle, all the way around a circle is always 360 degrees, which means all the way around a circle is always 2 pi radians. So what are we going to do to convert? Here's the big thing. If 2 pi radians is 360 degrees, that means divide by 2, divide by 2. 1 pi radians is 180 degrees. And that is the conversion that we will use. And you're going to use dimensional analysis. Whatever you want to get rid of goes on the bottom. If I want to get rid of degrees, 180 degrees goes on the bottom. If I want to get rid of radians, then pi radians goes on the bottom. So if I'm going to go from 30 degrees and I want to eliminate degrees and end with a radians, we use dimensional analysis. Notice the degrees cancel out. 30 over 180 is 1/6. If you're not sure about that, use your calculator. Remember, the math key has a fraction button, so you can do 30 divided by 180, change to a fraction. And then I get pi over 6 radians. And we always write them in terms of pi whenever we can. They don't have to be written in terms of pi. 2 pi is 6.28. 1 pi is 3.14. Pi over 6, there is a decimal, but we like to use it and leave it in terms of pi because pi is an irrational number. Okay, now I need to get rid of radians, and I need to go to degrees. That means I'm going to use this guy. The pi radians goes on the bottom. How do I know which way to go? Because I need to eliminate radians. Notice the pi's also cancel out. Notice this goes to 60 over 1. 180 divided by 3 is 60. I'm left with negative 5 times 60, which is negative 300 degrees. And if you think about negative 5 pi over 3, negative 6 pi over 3 is negative 2. So I'm a pi over 3 short, which is 60 degrees short. Okay? So when in doubt, let's grab these ratios. What are you going to get rid of? So think about going from miles per hour to feet per second. You've been doing that for years in math class and science class. You can make it go by using dimensional analysis. Let's try a couple more. I'm going to get rid of degrees, which means my 180 goes on the bottom. Remember, since pi radians is the same as 180 degrees, we can write this in terms of a fraction. This fraction is equal to 1 because these two things are the same thing. So now I got to simplify 210 over 180. A few different ways you can do that. You can do it on your calculator. Again, 210 divided by 180, hit the math key, change to fraction, and you should get 7 pi over 6. So when you do the 210 divided by 180 in your calculator, you don't include the pi. You're just knowing that you're going to add on the pi radians at the end. 5 pi over 6. Again, I'm in radians. I need to get rid of radians. The pi radians goes on the bottom, and the 180 degrees goes on the top. The radian label cancels out. The pi's cancel out. 180 divided by 6 is 30. 5 times 30 is 150 degrees. And if you think about 150 degrees, whoa, that's a terrible drawing. I'm 30 degrees short. And if you think about 5 pi over 6, I'm 1 pi over 6 short of making it all the way to 180. Because 6 pi over 6 would be pi radians, okay? Again, if you're not picking up what I'm shoveling here, all you need to remember is you're either going to make your dimensional analysis with this guy or with this. Whoa, 1180, what are you doing? What's going on there, soldier? Okay, so if you're getting rid of radians goes on the bottom. I'm getting rid of degrees, negative 315. And I'm getting rid of degrees, so I know 180 goes on the bottom because the degrees need to cancel. Pi radians goes on top. 315 over 180. I'm definitely going to need my calculator for that one, and I believe it's negative 7 pi over 4. Just a lucky guess, I guess. Okay, 2 pi radian over 3 radians. Get rid of radians and go to degrees. And we can hit radians, and we can hit pies, and we can hit 60, and we can hit 1, and we can get, boy, I'm getting a lot of 60s here, aren't I? 120 degrees, and things with 60s and things with 30s. I wonder why that's the case. Oh my gosh, let's go from here. All right, back in the day, you used to have to memorize this big wheel on where everything was. We don't do, whoa. You'll be happy to know we don't do that anymore. There are a bunch that you will end up memorizing on accident. 360 degrees is equal to 2 pi radians. If I divide them both by 2, I get 1 pi radians. If I divide those both by 2, I get pi over 2 radians. If I divide those both by 2, I get pi over 4 radians. Now, if I go back here and I divide them both by 180 by 3, I get pi over 3 radians. And then I divide that by 2, and I get pi over 6 radians, okay? These are the ones for 30, 60, 90s and 45, 45, 90s. That you will end up memorizing on accident, and that's a good thing, particularly if you are planning on attending pre-calc or college algebra. The sooner you can understand that 90 degrees is pi over 2, and 45 degrees is pi over 4, and 60 degrees is pi over 3, and 30 degrees is pi over 6, you can go from there. So you think about the one that we just had where I had 210 degrees. Well, 210 is 7 30-degree angles. And you start putting together these pieces that come up again and again and again, okay? So do I have to memorize these? Nope, because all you really need to memorize is this one. You should also understand that 2 pi is all the way around, which goes back to our circumference, okay? So if you know the dimensional analysis, you can always go through converting, and that's okay. I like to think of this as a different language. We speak degrees, we don't speak radians very well. Okay, so when you're first learning a language, you need to go from like if it's Spanish, you need to change it to English. You need to think about your English, your answer in English, and then you need to change it back to Spanish. So if we start in radians, we might need to change it to degrees, answer the question, and then change back to radians if necessary. Okay. Arc length, the length S around a circle. So now this is going to be a distance. S is a distance. Okay, and the great thing about this is we can take the radius times the radians, okay? And if you think about the circumference is all the way around, what is that? 2 pi r. That's the radius times the radians. That's exactly what we're doing here. But now we don't have to get a fractional piece of it. We can just take, as long as we are in radians, notice this theta must be in radians. Radius times radians, that's the arc length, a piece of a circle. So if a steering wheel on a monster truck has a radius of 11 inches, r equals 11, then how far does a point on the steering wheel go if we go at 210 degrees? So we're going from here and we're going around 210 degrees, and I want to know that distance. And S is the arc length, and it's equal to radius times radians. So the first thing I need to do is change 210 into radians. So I'm going to get rid of that, and I'm going to go pi, and I'm going to go 210 divided by 180, and then change it to a fraction is 7 pi over 6. We just used that one. The radius is 11 inches. The radians is 7 pi over 6. So instead of 2 pi all the way around, I'm just telling it how far did I go. 7 pi over 6, and then I'm going to take that. So I actually use the pi key on the calculator, right? So 7 pi over 6 is actually 3.665, which shouldn't surprise us. 1 pi is 3.14, and then 7 pi over 6 is just a little bit further than 1 pi. And then I'm going to multiply that times 11. And I get 40.3 inches. So that means it's traveling 40.3 inches. So we can find a point around a circle, how far it travels, by doing radius times radians. The steering wheel on a yacht has a radius of 16 inches. So now I've got a big old steering wheel on a yacht. It's 16 inches. How far does this point travel when we go 390? So we're going all the way around and a little further, 30 degrees further. So the first thing I have to do is change radius. Whoa, I need to change into radians. Excuse me, I'm one step ahead of myself. Holy Hannah. And we get 390, so I do 390 divided by 180 in my calculator. Hit the math key, change to a fraction. I get 13 pi over 6. Oh, I get it. 12 pi over 6 is all the way around, and we're a little bit further. It's because 2 pi is all the way around. So 13 pi over 6. So the steering wheel goes radius times radians. And we would multiply that out because it's a distance. So 13 pi over 6 times pi times 16. And I get 108.9 inches, which is, that's a pretty big steering wheel. So if you think about it, that shouldn't be too surprising. Okay, last one, a clock. Through what angle in degrees and radians does the hour hand of a clock rotate from 4 to 7? So I go 1, 2, 3 hours. Well, isn't that 1, 2? Isn't that 3 out of 12? Isn't that a quarter? Isn't that a fourth of the whole thing, which is 90 degrees, right? So 3 hours is 90 degrees. And which is, I think I remember, wait a sec, we could do dimensional analysis here, but if pi is 180 degrees, then isn't divided by 290 should be pi over 2 radians. Ah, so we can use those little quick tricks if we want to. You can also do times pi radians over 180 degrees. And then it says, if the hour hand is 6 inches, find the arc length. S equals radius times radians. So I'm going to do radius times radians, and I'm going to get 9.42, and it's inches. That's how far it travels when it goes from here to there over that 3 hours, the tip of the 6-inch hour hand. All right, we got a little worksheet for you. Just remember, dimensional analysis, don't get freaked out by radians. Everything's going to be fine.